Dear students, today we are going to talk about the refractive index stated in various forms. Well, you see, we have learned a few of these definitions which we are going to just discuss, but I believe that we must compile all the definitions, all the various ways in which we define refractive index together, so that we have minimum confusion about this definition. Well, you see, refractive index we have already defined, but still I shall be defining each and every way in which we define it one by one. Even if we have learned them earlier, I will be defining them in all together in sequence. The basic definition for refractive index of light is defined as the ratio of speed of light in first medium to the speed of light in second medium, and that is always equal to a constant which is known as refractive index of second medium with respect to first medium. We must be very careful about the meaning of second medium and first medium. What is second medium? The medium in which the light ray finally reaches after refraction. We will call it from now onward as second medium. And the medium from which the light is incident on the surface separating the two different mediums, that medium we call first medium, and now onwards we shall be calling it like that. Well, you see, refractive index is denoted by a symbol mu. Here you see mu, and to express refractive index of second medium with respect to first medium, we used to write like this: mu2 base 1. And this is equal to the speed of light in first medium, say c1, to the speed of light in second medium. Well, what do we mean by physically? What do we mean by physically? What do we mean by refractive index? Refractive index is an indicator by what amount the light will bend due to refraction when it changes its medium. That index is called refractive index. More is the bending, higher will be the value of refractive index. Less will be the bending, lesser will be the value of refractive index. Well, we also define one term which is absolute refractive index. When we take the first medium to be vacuum and second medium as any medium whatsoever we want, then the ratio of speed of light in first medium, that is in vacuum, to the speed of light in second medium, that is any medium selected, this ratio is a constant and is known as absolute refractive index of second medium. That means if we restate absolute refractive index, we will say that refractive index of second medium with respect to first medium when first medium is vacuum, the value is known as absolute refractive index. Well, you see, in case with some approximation, we can also take first medium as air. Then also we take this as absolute refractive index. However, this is an approximation. The true meaning of absolute refractive index is only when we take first medium as vacuum and second medium as the medium whatever we want to consider. Well, you see, Snell's law. Well, you see, before we talk about the Snell's law, we will also talk what medium is called denser, optically denser medium. Whenever the light ray incident from first medium on the second medium and on entering the second medium, if the light ray is bending towards the normal, here you see we have drawn a diagram in which we consider a light ray AC is incident on the plane which BC, which is separating rarer medium and denser medium, and then after refraction the refracted light is bending towards the normal CF. Then in this case the second medium is called optically denser medium. And the converse, if the incident ray after refraction moves away from normal, then in that case the second medium is called optically rarer medium. So here you see refractive index of second medium with respect to first medium. If its value is greater than 1, then the second medium is optically denser medium, and if that value is less than 1, then the second medium is optically rarer medium as compared to the first medium. Well, you see, now we talk about Snell's law. Well, any law is usually found after rigorous experimental work. Here Snell traced the incident ray and refracted ray for different mediums, and he found each time that if a circle is drawn at the about the point of incidence having some radius, and then a perpendicular were drawn from the edge of the incident ray and the edge of the refracted ray, taken the length of both these rays to be equal, and since we have drawn a circle, the length AC must be equal to length CG. And whenever this was done, after that he found that the perpendicular drawn from the end point of the incident ray on the normal and perpendicular drawn from the end point of the refracted ray on the normal, the length of these two perpendiculars, that is AJ and GI, the ratio of the length of these two perpendiculars were always found to be constant for any two given mediums, whatever be the angle of incidence, and therefore he came to a conclusion that this ratio is always a constant. And if we divide both these terms, if we have say AJ upon GI is constant, if we divide AJ by AC, it becomes equal to sin I. If you divide AJ by AC, it becomes sin I. And if you divide GI by CG or GC is sin R. And therefore you can very well see, if you divide these two terms, it again remains constant, and therefore we got the relation refractive index of second medium with respect to first medium mu to 1 is always equal to sin I by sin R. So this is the Snell's law. Snell's law is giving the observation in mathematical form, whatever he observed geometrically. So students, we have learned today two definitions, and further we shall be learning all the forms of definitions for refractive index together, so that you have least confusion about them, because usually it comes in the chapter after intermittent gaps, that I believe is not giving you all full view together. Therefore I shall be telling you all the definitions. Even if we have some trouble in understanding them, we will bear it to and to have the benefit of seeing the whole problem all together. That's all for today. Thank you and have a nice day.